Yeah, thanks everyone, and welcome. I'm Muayad. I'm Director of Engineering at Writer, and I'm going to tell you about LLMs in the wild, how we build LLMs, how we deploy them in multiple production environments, and the main thing is how we utilize Scala into building these LLMs and serving our customers. Yeah, hopefully you're going to enjoy this. First, let me tell you a bit about Writer. Everyone is asking what's Writer, what we are doing. So we're here to answer that. Basically, I would love to always start with like the story of Writer is the story of Transformers. We started in 2020, but our story start before that. We started with a translation company with the same co-founders. It's called Cordoba. And with machine translation, we used BERT, we used T4, T5 for our models. And then we found that LLMs will be big things. It's going to be, in 2020, we found out that models will be better in reading and writing, better than human even. And that's what we see now after 5 years. From the beginning, we capitalized on ever-improving LLM capabilities and providing these capabilities for our customers. From the beginning, we started to focus on enterprise, while everyone else was focusing on consumers. ChatGPT and the others, they mainly focus on end users. But for us, our steer focus was mainly on enterprise, because you're going to see in the slides, enterprise has its own challenges and its own difficulties, especially when it comes to LLM and generative AI. We built a lot of series of models. We started with Palmera Nemo. Our first generation, it was like early 2020. And then we moved to Palmera Large. Our models are top tier in the market. They are used, they're mostly open source and utilized by many enterprise customers. Also, we introduced Palmera X, and I think 2023, we introduced the Palmera chat model. And then we started to increase the model size. So Palmera X2 was 8K and then 32K. We introduced also Palmera Vision. Recently, our latest model is Palmera 5, which I'm going to speak about it, which has self-reflect and retry and rewards. It has adaptive thinking as well. At Writer, we have a both of research house, and also we have a product and engineering teams that bring value for our customer. And so it's not only technology. We have research, we build our models, and then we have our technology team and product team who build enterprise-ready applications to serve it to our customers, basically. Why LLMs, or in general, generative AI is very difficult in enterprise world? Probably you ask that. For many reasons, it's not you have LLM, or if you have access to LLM, you just deploy it on your environment and then you have access to it. It's way beyond of that. Basically, you have contextual data. You need LLMs by itself. It doesn't know much about your company context, about your company data. So you have data pipelines. You need to work on that in order to prepare this data to be indexable, to be reachable by LLMs. Also, you need to do embedding. You need to do vector databases and store this data in the vector. And that's what usually we refer to like in RAG, Retrieval-Augmented Generation pipeline. So all of this, they are not, it's not one piece of software that you just install it or you add it to your company and tada, you have generative AI. Also, on the LLM side, you have a lot of issues dealing with LLMs. LLMs usually are slow. You need a lot of caching, probably. You need a lot of governance. You need logging, guardrails. it's a big mess. It's not just one thing. Actually, a lot of enterprise who are trying to do generative AI in-house, they are failing very rapidly. A lot of pilots that's happening or happened in the last 2 years, they failed. Not because of generative AI is not a good tool. It's mainly because they are not able to implement it in the right way. They don't have the right expertise to implement it as organization-wide. A recent report came up from MIT, shows that 95% of generative AI pilots at companies, especially enterprise one, are failing already. And that's what we notice, what we see with our customers, basically. Again, because you have a lot of fragmentation of enterprise data and AI, right? Stack. You have lack of domain specificity as well. You have, you need, as I mentioned, a vector database expertise. You need embedding expertise. You need, for example, also, of course, generative AI expertise, LLMs, serving the LLMs, and so on. For example, lack of clarity on foundation model. Foundation models also, they are changing very rapidly. So many organizations we saw that they integrated with one model, and then 6 months ago, this model is deprecated. There's a new model. And the upgrade path is not that easy, because you need to think about the model like you are talking with a person, right? When you have newer version of this person, it's, you're talking with a different person completely. So your prompts will be out of date. Your solution, basically, it's not going to yield the same results as it has before. So there is a lot of challenge on the upgrade as well. And of course, a lot of governance, a lot of monitoring, because again, the same stack of softwares that we know now does not work with monitoring, with alerts for LLMs and generative AI in general, because the output is not deterministic. LLM can spit, many content. It's not deterministic content, so you can have simple rejects or simple match. So you say, okay, alert on this or that. And here comes Writer, and we are different than others because we have our AI research lab, and we focus on enterprise. We are targeting to have AGI for enterprise in the coming years. We have a set of our Palmera models. They are all built in-house, and we have our novel knowledge graph. Self-evolving models is something we're actively working on. Self-evolving model, think about it like its model can learn from your data, from your employees that's interacting with this data or these models on daily basis. So that's the research, and that's what we have dedicated teams for this. And also we have the platform, and this end-to-end platform. So basically, your team can build agents. They can build AI flows and agents. They can activate them. So basically, they can distribute them in the organization in a safe way, in controlled way. And also, they can supervise it. They can see the loggings. They can see the monitoring. They can basically have access control over everything. And of course, because generative AI is not software only, it's also mindset. So also we do deep partnerships with our customers. We have dedicated customer success team, customer AI architects. They work closely with our customers to help them to implement generative AI. Again, it's a transformation journey for any enterprise to introduce generative AI. There are a lot of sometimes like pushback from IT, pushback from some, the governance entity usually in the organizations. And having these controls or working with Writer help a lot into introducing this and make it much easier. We have a lot of also training and COE as well. Our products range into, let's say, 4 pillars. So the most customer facing is Activate. So we have, for example, our agent library. It contains a lot of industry-specific agents, like pre-built agents, come out of the box with Writer. And they are also like top-tier agents that they are fine-tuned for that specific industry. We have Ask Writer. Ask Writer is a chat interface over your big data. You can connect it to your data, to your knowledge graph, to your Confluence, to your GitHub, and ask question over it. You can also iterate over that follow-up questions with a lot of citation, a lot of references, and so on. And then we have the build. So we allow or we enable some departments to build their own agents. It's not only like the agents that come with Writer, so you can build your own agents. So we have agent templates, we have agent builder, basically. You can build agents and you can deploy it in Writer and in multiple environments that you have Writer at. And of course, supervise is a big part of Writer as well. So you have full control panel, you have full control over these agents, these generative AI logs, and the data control that you have. And beneath all of this, we have the platform where of course, we have our Palmera models. We have domain-specific models like Palmera Fin, Palmera Med, Palmera Creative, Palmera Vision, and they are all top-tier models in the market. Like we get, I think, number 3 or 4 in the Helm charts compared to other companies. And of course, we have the knowledge graph. So knowledge graph, basically, it's a graph that represents your internal data in the company. Yeah, these are the models that I talk about. Palmera 4 has a context window of 128K tokens. It was top ranking on Helm charts. Palmera 4 has advanced reasoning with tool calling, with LLM delegation coding as well. But our latest model, which is Palmera 5, here. Yeah. Palmera 5 has 1 million context window. So if you are not familiar with context window, basically, it's the input for your model, for the LLM, how much text or how much tokens can the LLM take as input. So compared to Palmera 4, where we have 128K, now we have 1 million, and that's almost represent 1,500 pages. So imagine like you can put not only books into the context, and you can ask question there. This has a lot of breakthrough in the research as well. We have adaptive reasoning. Also, like tool calling is being like very popular nowadays, especially with MCP. So tool calling is very important now. Basically, what's adaptive reasoning, just in a brief, basically it's query complexity classification. So we can classify the query complexity, and based on that, we can route the query into multiple parts in the model. So that's why you get light speed. If you see, like if you compare it to the previous one, for example, this one, for 1 million token, it's under 22 seconds, and the function call is less than 300 milliseconds, which is like, if you think about it, like it's really just an API call, basically. Also, with adaptive reasoning, you get like the model can change the strategies based on the context. They can fall back. They can explore multiple solution or multiple generation paths at the same time. And then based on the context, it can fall back to one of them or concentrate its power on specific one. So that's really advanced model. And on top of all of that, it's the lowest cost in the market. You see the price there. So what does a writer behind the scene look like? We have a writer ecosystem On the Activate, we have this application layer where you have Ask Writer, you have Retrieval-Augmented Generation, you have multiple AI agents, and of course we have our API and SDK and the framework. And on the right side, we have the LLM inference providers. So we deal with multiple inference providers, like Amazon Bedrock. Recently, our models are available there. We have partnership with Base10, and of course, we have our own hosting for the model. This is very important because you don't need to deal with one inference provider, because with LLMs, it's get very tricky if you have high load. So you need to route from one provider to another provider. You need to do fallback. You need to do the right routing, advanced routing that we have. And in the middle, we have the writer platform, or what we say, platform and supervise. So we have caching for the model responses. We have access control. So you can control the access for your data, for your models as well, who can access what. And we can also track the usage and the billing. So you know who's using what. And also we can do the rate limiting. Rate limiting is important because you don't want, like in multi-customer environment, you don't need some customers to overuse in favor to other customers. We also support audit logs, and all of these are what empower actually the enterprise, basically, enterprise use case. We have advanced LLM routing. Advanced LLM routing is very critical because in order to serve all of these users in reliable way, it's not enough to rely on one provider. You need to calculate what's the load for each provider. There are GPUs at the end, and they can get busy very soon. And scaling up GPUs is not that easy. It's not like CPU. Within a few seconds, less than a second, basically, you can spin up CPU. The models are huge, so also loading the models into the GPU is taking time. So that's why you need to do what we call it, basically, it's request planning. So you need to do request planning and route to the right provider. And also you can do provider fallback. So if some providers give you errors, returns error, then you can fall back to another provider very easily. And all of that, by the way, it's transparent. It's happened in the background. Users will not see, will not notice anything. They will just get the response. They will get the stream back with no effort. And of course, we support multimodals, so vision, video, all of that. We have also prompts management, and of course, on top of that, we have metrics, alerts, and tracing, and that's what empower the enterprise again. MCP gateway is something we introduced recently, since MCP is getting more popular. Probably it's need a separate talk. I'm not going to cover a lot of MCP in this talk, but it's very interesting topic to speak about. Yeah, now I think all of you came here to know what do we use Scala at in Writer, why we are here. So Scala, we adapted Scala a long time ago from the previous startup, Cordoba. So it was like 2013 when we started using Scala in production. And that was the natural choice for us when we started Writer. We utilize all Scala, or basically the stream Scala ecosystem. We utilize Tapir, we utilize CATS effects, FS2 and HTTP4S, plus a lot of tools that we build in-house. And basically, Scala power most of our back-end services, most of our data engineering, and most of our data pipeline, RAG pipeline, microservices, all of that is managed by Scala. Document parsing, extraction, all of that powered by Scala. LLM gateway is powered by Scala as well. And of course, we use all the way functional programming, and as I mentioned, these tools here. Okay. And why Scala, basically? I mentioned before that LLMs are not perfect. It's not easy to deal with LLMs for many reasons. LLMs do a lot of hallucination. The inference has a lot of latency, especially if you wanna serve the entire response all at once. If you're gonna, because LLMs usually generate the tokens, generate token by token. So if you wanna wait for the entire stream or entire response answer to be ready in order to serve it to customer, you see, like usually it's going to be high latency. Sometimes it takes a few minutes to get the full response from the LLM. So that's why streaming is a big thing in generative AI, and we'll see how we achieve that with Scala. Errors. LLMs, they generate a lot of errors because of the high load on the GPU. When the GPU gets stressed, they can do nothing other than throwing errors. And scalability, you cannot scale easy as CPU. As I mentioned, LLMs are models usually, especially the weights that are large. It's take a few minutes sometimes in order to download them and spin new GPU, basically. So that's why we need to have a robust solution in order to do error handling, in order to do routing and fallback. Prompt leaking as well is one of the biggest problem in the LLM. So basically, LLM can output your system prompt to the customer. And the hallucination, usually hallucination, you control it with a lot of guardrails and grounded with business data. So if you provide the LLM with the right grounded data or your company data, then it will be it will not hallucinate. So yeah, that's why streaming is very important with LLM. As I mentioned, LLMs generate token by token, and then before it sends them basically to the backend service, it's batched them into batches, small batches. But like this is not very visible here, but not sure, yeah, you cannot see it. Yeah, but basically the LLM tokens. So the first step is that the model gonna tokenize your input into small chunks. The token could be like few letters to like 1 letter, 2 to 3 letters, and then it's convert that to numerical representation, basically the index of this token, because at the end the models only deal with numbers, right? And on the other side, it's also predict the output token as number, and then it's converted back to the token based on the on the dictionary that it has. So yeah, basically that's why streaming is important. So you need to stream token by token or chunk by chunk. And usually with LLM streaming, you have two-way stream. So you have the LLM, you stream from the LLM to the backend service, and then you have a stream from the backend service to the front end in order to be visible to the customer, right? That's mainly now the standard protocol for that is server send event. Server send event is protocol over HTTP. It's used text-based meme type. It provides auto reconnect out of the box. It's supported by most of the browsers. On the opposite, you have the WebSocket. WebSocket is bidirectional, and SSE is usually, or it is unidirectional. So only events can be sent from the server to the client, to the browser. You cannot, browser cannot send events to the server. And this is ideal for LLMs, because usually LLMs is outputting these tokens, and the client is receiving it. And the auto reconnect is a big gain here, because you don't need to manage that at all in your client. While in WebSocket, for example, even though it's bidirectional, which is in some cases it's better, for example, if you are building chat application or gaming or something like that, where you need like collaborative streams or events from both sides. But it's harder to maintain, you know, you need like some stateful state management on your server. You need to scale that. It's more complex to scale. While with server-send event, it's stateless. You can basically open connection, and if it's reconnect, you can reconnect to any other server. It's supported by all the browsers. Yeah, this is one example about SSE request. This is using Writer API. So basically, you send the model name. You send the temperature, which is like how much you want the. Of course, there are other parameters, but the temperature, for example, control how much your the randomness in your generation. Do you want it? Do you want your output to be very coherent, or you want it to be a bit random, or allow the model to be, let's say, more creative? That's how we describe it. And then this is like the list of messages that you have. This is like now a standard protocol that you know, you have the role of the sender who made this message. It could be assistant or user, and then the content. For example, here, like I'm asking, how are you? And the most important part is the streaming part. So you need to set streaming to true in order to get back streaming. Otherwise, you'll get just normal HTTP response with JSON in there. And usually the response in this case, if you set streaming true, it's going to be like patches of content, like line by line. Sometimes, of course, like you need like, because of the network, right? And then there are bytes. You'll get like half line, so you need to combine them together, and so on. So basically, you stream chunk by chunk, and this is like the protocol. So basically, you have the data column there, and then space, and then you have your data. And usually, we use JSON for that, so we can parse it well. And at the end of the stream, you have done to make sure, like, okay, to know that the stream was done. It was not like disconnected or something. Okay. So why SSE is important? Because with SSE you can auto retry, basically. So the client, they can detect if the SSE connection get dropped or stalled, then they can retry that. And all of this happens in transparent way. All the retries happen without the user intervention. On the back end also, if we use server-send event, we can do a model. If the model fail or if it exceed some latency threshold, we can just fall back to another model or even to another provider even. And all of that, it's happened behind the scene. So for the user, basically, if you ask question or you know, ask for some information or generate a new content, you just see the stream is running. You know, you'll not notice all of that. Basically, you'll see, oh, nothing happened. Before I move to the code, I just want to highlight like why we are using Scala and why we think Scala is much better than now the standard, let's say, the most common generative AI language, which is Python. We got a lot of questions about that. Why you don't use Python? Why you are insisting on using Scala? I explained how streams are important, and concurrency, of course, with the streams is also more important because you are not serving one stream at a time. You are serving millions of streams at a time. With Scala and with JVM in general, you have a truly operation system level threads. You have much efficient pools than what you have in the other languages. We are using at Writer CATS effects, and with fibers, it's give us great flexibility, great concurrency advantage as lightweight threads. While, for example, in Python, if you want to compare GL restrict the parallelism, it's good for CPU. It's good for basically for I/O bounded, but also when you go for any CPU bounded task, it's going to be limiting you there. You need to go to multiprocessing, which it's much complex, and I'm not sure if you tried that, but most of the engineers they try to avoid it. Safety, with Scala you have a strong static typing. The effect system enforce the safe concurrency at compile time. So you make sure like, okay, your streams will not be mixed, your data will not be mixed, it's not gonna be disconnected or something. While in Python, this usually is enforced only at runtime, which cause a high risk of race conditions usually. And of course, with Scala, concurrency primitives is much better. So you have like fibers, you have structured concurrency, you have typed actors, for example, and also you have STM, which is the software transactional memory. You have also very easy out-of-the-box reach backpressure with CATS effects with FS2. And also you have much more control. You can cancel your stream, you can cancel your fiber much easier than what you have with Python. With Python, maybe like the most common library there is async.io, which is the basic implementation for event loop. It works well for I/O bounded tasks, but it fails when you have CPU bounded tasks. And backpressure is completely manual. You don't have it out of the box. And it has a lot of error prone. Basically, compiler does not help you there at all. Some of the libraries that we utilize from Scala ecosystem, we use CATS effects for pure functional effects, fibers, and resource safety. We use FS2 for pure streaming with backpressure. So this is ideal in our case for LLM streaming. And we use HTTP4S with Tabir for our web servers. Okay, now it's time to go to the code. Okay, well, I think you don't see my screen, so let's go here. One second, I need to escape this. Need to move this here. Okay, is it visible for you? Great. So yeah, for example, here we have stream, how we use FS2 in order to consume LLM response. So we're calling writer API here. So basically, I have the request here. I'm specifying the key, the headers, the body. Usually, the same body is just JSON representation of the messages and the temperature and the others. And then we consume the response as a sealed stream. This is like from FS2. Basically, it just makes sure like you have your streams and you have a timeout, so you can time out if in case your stream disconnected. And And also you see here, we are piping with multiple, because since it's stream, so we pipe multiple processes in between. So we do a lot of metrics. We count, for example, the tokens. We do some also buffering, so we can apply the guardrails, because for some guardrails, token does not make sense, right? If I say I, you cannot say, okay, what does it, is it something that like that should pass your filter or not? So we do buffering there, and then we parse the streaming response. We have here service and event decoder, which is supported out of the box from FS2. It was great help. And then we can check on the finish reason, because sometimes the LLM finish earlier, either because of the context window. Maybe the context window is already like fulfilled if you provide, especially in the older days, when the context window was in 100K, 120K. Now with 1 million, hopefully we will not get this a lot of finish reasons. Another thing here, we wait for the first token in the stream to see if this is an error or actual response. So this is important, and it's make it easy for us to identify and fall back in case of error. We can fall back to another model or another provider, as we mentioned. So it's really handling errors in a nice way. Okay, you see here, for example, as part of our internal library, we have logs that we can assign to any internal method, basically. And this log's gonna print with it the entire stack, the entire tracing that we have in the request, basically. I'm gonna show you also the fallback. So yeah, you see here, for example, this is gonna it's gonna basically try multiple models in order to get your first successful generation, and it can switch the stream in or during the stream. Basically, it can just restart the stream and start. Let's say it's in the middle of the stream, you get a connection error, or you get 502 error from the model. It can just restart the stream and send it or route it to another either model or provider. So you see here, you have the original model, the original stream, and the fallback. So if you have any error, we can fall back, and we can record that fallback actually in our metrics. Even we have a latch. So basically, if some model of some providers returned a lot of errors, we can just shut it down, and for next 5 minutes, for example, we don't route any request there. So this is like very advanced routing. Okay, that's mainly about streaming. You wanna take it? Yeah. I have Jack here, who's gonna speak more about Scala tools in Writer. How many minutes we still have?
We're basically out of time.
Oh, over time? Oh.
2 more minutes to wrap up.
Okay, yeah. Yeah, let's quickly go through them, and then we can take questions, if any. Yeah.
Yep. So some things that people have asked this week is, why do we use Scala? Well, we have a huge domain, we have a huge customer base, and we have a small engineering team. So we need to be productive, we need to be consistent, we have to provide tools that make it easy to handle errors. We have to, we're a small team. We were a small startup, right? We weren't always huge. We didn't have money all the time. So we built a lot of tracing stuff in-house, And when we expanded and got bigger and added more services, we used the same abstractions over and over and over through our service-oriented architecture to make us productive day to day. So some quick things I'll give a note. We use an RPC library that's called Poppet. It's been built in-house. It's a type-safe RPC library, and it supports Scala 3 and Scala 2. What it does is we define an abstract service. It generates a consumer and a producer from us. When we go to other services, we can call that just like we're calling local Scala code. It's protocol agnostic, so it'll handle SSE streaming and JSON. Another thing that we use either T to guarantee type-safe errors. So all of our expected errors are handled. When we get an unexpected error, we know, we wrap that in a fail, and then we return the proper response for that. Kleisli is our UR abstraction. It allows us to do all that tracing, add additional context to anything, and when you showed the logging earlier, that automatically reads from that context and can add extra information to our logs, which will help us in debugging whenever anything goes wrong. And then both of these, we've written integrations with Tapir to make it easy to write APIs for the line Scala coders on our team. Of course, we do use Tapir. We use it as a unified API interface. It's got open API spec generation. We consolidate in a library. We consolidate all the header management across all our services. And our front-end team uses the open API specs generated by our Tapir backends to then generate their front end. It's a tremendous advantage for them to be able to do that protectively. And then we do use Mill. It's our main build tool. We use that because of the fast startup that Mill provides us in CI/CD pipelines. If you can imagine, we're doing hundreds to thousands of builds a day. Well, we need to be able to run those fast. And we also have our own organizational plugin that allows us to organize all of our linting, checking, tests, dependency management across our pipeline. And that allows our users to be very, very productive at work.
Thanks, Jack. Yeah, we are hiring, so you have also a booth here. Just feel free to stop by and take some goodies. Thank you. Questions or
Unfortunately, we don't have time for
maybe
questions,
one question,
but you can definitely talk.
Yeah, if you have any question,
or
just
outside.
we'll stay here to talk about it. Thanks, everyone.